So our next concept is displacement current and displacement current density. So this concept was introduced by Clerk Maxwell. So in the second unit, that is conductors and dielectrics, we are already defined this displacement current and displacement current density. So then how can we define this displacement current here? So at that time we are defined the current flowing through the dielectric medium as a result of time varying electric field is called displacement current. The displacement current per unit surface area, normal surface area, is called displacement current density. Now in this chapter we will go for the expression for displacement current and displacement current density. So see here, the current flowing through the dielectric medium as a result of time varying electric field is called displacement current. Is called displacement current, denoted with ID. Then displacement current density, displacement current density represented with JD bar because of it is a vector quantity. That means the displacement current per unit normal surface area, normal surface area is called displacement current density. That is JD is equal to ID by A in magnitude, ampere per meter square, magnitude. So then in vector quantity, JD bar is equal to ID by A into AN bar, or otherwise DID, differential current divided by differential surface into AN bar, which is equation number 2 in vector form. So now the expression for displacement current density is JD bar is equal to dou D bar by dou T. So now we have to derive it, prove it. JD bar is equal to dou D bar by dou T. So then now expression for displacement current density, expression for displacement current density, JD bar. So now see here, let us consider a capacitor of capacitance C and a time varying voltage and a time varying voltage is applied across it as shown in figure. So then this is the capacitor and here a time varying voltage is applied and the capacitance of capacitor is C. So then now this is the current flows through the capacitor. So here for capacitor actual current, that is conductional current, IC is equal to displacement current ID. Why? What is the reason? Why the displacement current is equal to the current conductional current in a capacitor means if we can consider a capacitor while charging the capacitor, so here is a phase and here neutral, the current flow direction is like this. So we are already discussed in first unit network analysis or your electrical circuit analysis, electrical circuits. So for alternating voltage we have to supply the capacitor which can act as a short circuit. In tangents also you are discussed that the capacitor can oppose sudden changes in voltage. That's why at the time of t is equal to 0 and t is equal to 0 plus, which can act as a short circuit, so that means for alternating voltage which can act as a short circuit, that means which can allows the currents for time varying voltages, that means the current can allows, that means the current direction is like this while charging, and while for discharging the current direction is from like this while for discharging. That means in these two ways the current can follows only one particular path, only one particular path. In that path dielectric medium also there, that means these two parallel plates are separated by a dielectric medium. Whatever the current produced by the supply that can flows through the dielectric medium as well as electrodes, electrodes means two parallel plates. That's why here there is only one current, that is supply current, that is equal to the current flows through the parallel plates, that means conductive plates, and current flows through the dielectric medium. The current flows through the conductive plates is called conductional current, and current flows through the dielectric medium is called displacement current here. So that means here it is that only one current is there, that is displacement current, conductional current, and total current, supply current. That's why in case of a capacitor the displacement current is equal to conduction current because of there is a single path only. So then now we can derive an expression for displacement current of displacement current. So then in capacitor IC is equal to C into dV by dt, which is the first equation. So then we know that C is equal to, that means capacitance of parallel plate capacitor, epsilon A by D. Then substituting equation 2 in equation 1, we get IC is equal to epsilon A by D into dV by dt. So then which is equation number 3. So the electric field applied to the capacitor due to time varying voltage E is equal to V by D, volt per meter. Then from this applied voltage V is equal to E into D. Then substituting equation 5 in equation 3, we get IC is equal to epsilon A by D into d by dt of V is E into D. So then dd both are get cancelled out. Then conductional current IC is equal to, which is epsilon A into dE by dt, which is equation number 6. But the conductional current density Jc is equal to conductional current by area. Substituting equation 6 in equation 7, we get I Jc is equal to epsilon A dE by dt divided by A both are get cancelled out. Jc is equal to d by dt of epsilon E. So, but epsilon E is equal to d. Then Jc is equal to d by dt d bar. Here vector quantity. So here it is, the voltage is a time varying voltage. It is dou d bar by dou t. So for capacitor, Jc is equal to Jd, then Jd bar is equal to dou d bar by dou t. So which is the expression for displacement current density,